Welcome. In this video, we're going to determine whether this infinite series converges or diverges. Now, I'll be showing you how to do this using the limit comparison test. And just so that I don't have to write this down too often again, let's call this whole thing a sub n. Okay, so let's begin. Consider b sub n equals, and let's just use the leading coefficients on the numerator and denominator, that is n squared over 3n to the fourth. This is equal to 1 over 3n squared. Now we can apply the limit comparison test, that is the limit as n approaches infinity of a sub n over b sub n. Well, that is equal to the limit as n approaches infinity of this rational expression divided by this rational expression. This can be rewritten as a product, that is the limit as n approaches infinity of 3n to the fourth plus 6n cubed plus 9n squared divided by 3n to the fourth plus 11n squared minus 7n plus 5. Now the numerator and denominator both have a highest power of n to the fourth, so let's go ahead and divide the numerator and denominator by n to the fourth, which is the same thing by multiplying 1 over n to the fourth to both. This yields the limit as n approaches infinity of the rational expression you see in front of you. And if you don't see how this became this, please pause your video and apply the distributive property on the numerator and apply the distributive property within the denominator as well. Okay, well, this is just going to equal 3 over 3, which is just 1. Since as n grows larger and larger, each of these terms I'm crossing out now is going to approach 0, since we are going to have a fraction with a finite number on top for each of these cases with a number on the denominator that's getting larger and larger. That'll leave only the 3 over 3, which is just 1. Okay, now let's go ahead and write our conclusion out. So the given series, and I'm using the given series since I don't want to rewrite this mess, resembles this series, which converges. This is a p series with p equal to 2, which is greater than 1. Now, since the limit as n approaches, and actually let me write this out as a full text sentence. Since the limit as n approaches infinity of a sub n over b sub n, and when I say a sub n, I mean our original series divided by the series it resembles, equals 1, which is not equal to 0, it follows by the limit comparison test that our original series, which I'll rewrite out this time, also converges. I want to point out that the limit comparison test, since the limit is not equal to 0, both of these series either converge or both of these series diverge. But since we know this one converges as it is a p series with a p greater than 2, then this series also has to converge.